for data frame, basically, we will create artificial neural network, and we will try to predict the churning of customer in the bank using artificial neural network. Okay, that we will do here. So here we will start with this artificial neural network. Okay, so first we need to import all the packages like shown here. Import NumPy, we'll import the TensorFlow, we'll also import the pandas. Okay, now after importing it, I'm just checking what is the version of this TensorFlow package. So tf dot version. Okay, that we usually what we do here. Okay, so I am using 2.4.1. The version is 2.4.1, and I hope everyone is having the same one. Okay, now after that we will just import the data set. So pt.read csv, and we'll import the data set simply. And I'm just checking the head of the data set. What are the different rows and columns here? And I know that this row number, customer ID, and surname is not required for me to predict the churn. So I'll just drop these three columns: row number, customer ID, and surname. So here I'm dropping these three columns. Okay, and I'm saving all the other values in this format in one, say, X. Okay, and the final value, the target value, which is dependent variable, which is called existed or not, 0 or 1, means the customer churned or not, that I am saving it in Y variable. Okay, now I am checking the X variable and Y variable like that. So it's in the form of matrix, by the way. Now it's in the form of matrix. So as you know, the neural network will take the inputs in the form of matrix. Okay, so that's why we had to do in this form. Now after that we have to encode the categorical data, right? So we will now encode the categorical data. How we will encode the gender value by using the label encoder. Since the gender is having only two values, two labels, say 0 and 1, or say male and female. So I'm using the label encoder here. Okay, by using the label encoder, I will encoded the this one into 0 and 1, the male and female into 0 and 1. After that, I have another categorical column which is called geography. And for this geography column, what I'll do is I'll create the one hot encoding, because this geography is having more than two labels, more than two factors. So I'll do one hot, I'll apply the one hot encoder function on this column called geography. Okay, so I'm using that. Now after that, we will split the data into training set. I'll do the some kind of feature scaling. As standard scaler, I'll just externalize all the variables, and after that I will initialize. I will do the ANN part, artificial neural network part. How to do the artificial neural network part? So in the artificial neural network part, first we have to import the model from the Keras or tf.keras, right? If you are using directly Keras, you can use that, or this Keras is also wrapped inside the TensorFlow library, TensorFlow package. That's why we can also use tf.keras.models.sequential. So we are just importing the sequential model. See, all the TensorFlow all the neural network models are sequential in nature. Sequential. So I'm importing the sequential model. From the models, I'm importing the sequential class. Okay, and after importing, I'm saving it in ANN. Now what I'll do is after doing it, what do I need to do? Right? That's a question. So as we used to create one input input layer, hidden layer, output layer, multiple layers we used to create while creating the neural network, right? Similarly, we'll do here also. So since we have created the object of this model ANN, now I'll add one layer to it. ANN.add tf.keras layers.dense, and then I'll say that there are 6 units in that, and the activation function used is ReLU. It means it will take all the inputs. The by default input layer is created, and after that I have to take care of the hidden layers basically. So I am creating one hidden layer with number of neurons at 6. As you can see here, units equal to 6. So I have given the number of neurons as 6. And in this hidden layer, I'm using the activation function as ReLU. Okay. So what you can do is you can chop up this one till this one. So you can import from TensorFlow dot keras dot layers, import layers. That you can also do. And here you can directly use layers dot dense. You can skip this one. Okay. There's a different options here. Okay. Now this is my one of the hidden layers here. Now I am adding the second hidden layer again the second hidden layer I am adding. Again I am saying that there will be 6 neurons in the hidden layer, second hidden layer, and again I will be using the ReLU activation function. Okay, I have 2 hidden layers now. Now finally I'll say I'll add one output layer in which I will say there will be only one neuron in the output layer, because we have the classification problem and it will either give the probability value, and we will say that if the probability value is less than 0.5, it belongs to class 0. It will not churn the bank. If it belongs to, if the probability value is more than 0.5, we will say that customer will churn the bank. Okay, so we'll take the decision. So we need only one neuron here, not more than one neuron. Okay, so activation function required here will be sigmoid, because it is a binary classification, basically classification problem. We need probability. So sigmoid function will give you the probability values between 0 to 1. Okay, so this is the probability value. Now I have till this one I have input layer. From the input layer basically, after 2 it will, all the inputs will go to the 2 hidden layers after that. And after that, after passing through the 2 hidden layers, it will finally pass through the output layers. Okay, in the output layer, it will give you the values of the probabilities between 0 to 1 by using the sigmoid function. In the hidden layer, I have used only the ReLU activation function. Here, no concept of convolution, max pooling, or say fully connected layer will come into picture. Why? Because we don't have images here. We have simple data frame, right? So no concept of convolution will come into picture here. Okay. Now the part 3 is training the artificial neural network. We have to train them, right? So here, to train them, first we need to compile it. Compile the model which we have created. How will you compile? Just the model name ann.compile. Within compile, it will ask for some hyperparameters. What are those hyperparameters? First one is optimizer. How will you optimize the error? Okay, how will you optimize the error? So how will you calculate the error basically? So we'll calculate the error by using the Adam optimizer. What is this Adam optimizer? It can perform a stochastic gradient descent. While calculating the gradient of the error, it will calculate the stochastic gradient descent. What is stochastic gradient descent? Stochastic gradient descent means for each of the training samples, it will create the gradient, it will calculate the error, and it will update the weight. This is called a stochastic. Another one is called, this is similar to the online. Three different types of updation methods we had, right? Online, batch, and mini match. So this is similar, exactly similar to the online batch updation method. A stochastic. One by one, it will be updated. Okay. Now the next one is loss. Loss equals to binary cross entropy. As we have learned in the last class, what is binary cross entropy, right? So binary cross entropy, we are using the loss. We are not using the validation loss. I mean, simple a squared loss. We are using the binary cross entropy loss. Why? Because it will not have the problem of vanishing gradient. That's why we are using the binary cross entropy. And matrix equals to accuracy. The matrix to choose at the final output layer how it is working, how your model or network is working, how it is getting trained, what is the performance of your model, we will use a metric called accuracy. Okay, so these are few of the inputs or hyperparameters that are taken by the this compile method. Okay, after we have compiled, we have to fit the model. So while fitting the model, again it will ask for few of the hyperparameters, which are fully hyperparameters. While fitting the model, we will provide the input one, the independent variables, the dependent variables or the labels. Along with the labels, we have to provide the batch size and epochs. What is batch size and epochs? So suppose you have 10,000 images, okay, 10,000 image samples. When you provide all the images at once, it will take some time. So what you have to do is you have to provide in batches. Suppose batch size is 32. It means 32 training examples, 32 number of rows will be selected at random and it will be processed. Again, next 32 will be selected, it will be processed. Similarly, it will be done. Okay. So the number of training examples in one forward and backward pass. The higher the batch size, the more memory space you will need. So that's why we have to provide the batch size. Okay. Similarly, epoch. What is epoch? So one forward pass and one backward pass of all the training examples is called epoch. One forward pass means what? When you pass the training example, after that wait back propagation. This is one set, one epoch. Of all the training examples, this is one epoch. So for all the training examples, we will do 10 epochs. It means for all the training examples, there will be set of 10 forward and backward passes. Got it? Okay. Then we are training the, when we will run this one, it will run epoch on epoch. Epoch first out of 10 epochs. Total 250 training examples. Okay, forward and backward, everything. So loss, what is the loss? This much is the loss, means error. What is accuracy? Very less accuracy, 47.96%. After that, after the epoch 2, it is learning more better. What is the loss? It has drastically decreased to 48.98% from 72.33%. Now the accuracy has also drastically increased to 79.9% from 47.96%. Again, it is increasing slowly, or decreasing. It has increased till 85.39%. Okay, so till here we have 10 epochs. If it will further increase if you train the neural network more with more number of epochs. If you give the epoch as 100, it will be able to learn more and more. Okay, so they are the hyperparameters basically. And after that, we'll simply use a prediction. Prediction means suppose I am giving the geography as France, credit score as 600, gender as male, age 40 years old, tenure 3 years, balance 60,000, number of products 2. Does this customer have the credit card? Yes. Is this customer an active member? Yes. Estimated salary 50,000. So should we say goodbye to that customer? It means, will this customer churn the bank or not? That is a question. So by providing all these parameters, okay, see all the parameters. See, here I have, since this France or the geography is one hot encoded, right? So whatever the values, whatever the different labels, we need to provide in the same format. Okay, and after that, each and every variable we are providing it here. Finally, it will tell the probability of this one, probability that whether the customer will churn or not, probability of churning. So it will say 0.0383, it means 3.83% only. It means we have the probability of churning as 3.8% only. That means we can easily say that this customer will not churn the bank. Okay, now we can predict the test results. We can predict the outcome variable on the test set by using the same model. Okay, so NN dot predict X test, the same as we used to do in random forest or decision tree, anything. Okay, the same thing. Now I'm setting a rule that when y predicted value is greater than 0.5, then we can concatenate. Then we can take that this is like, yeah, it's 1 or 0 depending on that. Okay, I'm making the confusion matrix. Confusion matrix, we have found the accuracy as around 85%, 84.8%. So this is a very simple neural network architecture, guys. Very simple neural network architecture.